Hello, I'm Emin Erdem Kumbasar from the Electrical Engineering Department. Today, I'm going to make a presentation about my Physics 102 project. Topic of my project is motion of a magnet inside a conducting pipe. My goal is to understand how the magnetic induction works and how it changes depending on different variables. In my experiment, I used three different pipes. Each of these pipes are conductive and made of copper. I will use these pipes to release the magnets inside. The difference in these three pipes are their radius. From the smallest to biggest, the radius of these pipes are 0.75, 1.25 and 1.50 centimeters. I will use two magnetic balls. I will drop one of them inside the conducting pipes. I will release it from different heights in each pipe. The second magnet will be used to hold the ball from outside. I will use a ruler to measure the heights that the magnet will be released. By using a post-it and a pen, the release points will be marked on the pipes. Also, I will use a stopwatch to measure the time it takes for the magnet to reach the ground. I will show how I do the experiment with using the pipe with radius 1.25. In the experiment, I place the magnet by putting it inside while holding the other magnet closed outside, as you can see right now. This way, I can control the magnet and place the magnet in the height I want to. At first, I will drop the ball from 60 centimeters height. I will use a ruler to measure the distance and put a mark on the pipe using a pen. Also, I will start the stopwatch before I do this. Afterwards, I will pull the magnet away, as you can see. And a voice will come from the ground when the magnet hits the ground. I will repeat this 3 times in order to get more accurate results. From my calculations, I have reached that conclusion that the magnetic force is increasing as the height is increased. I calculated this force using Newton's second law and calculating acceleration from distance and time. My result for each pipe proved that the magnetic force is increasing as the distance is increased. Also, I have found that as the radius of the pipe increased, the magnetic force decreased. This is because how magnetic induction works, since as the conducting material is closer to the magnet, it opposes the motion with a greater force. In my experiment, one place where the values were not too accurate is when the magnet is released from the 20 centimeters. For example, in the pipe where the radius is 0.75 centimeters, the magnetic force values are respectively 0.970, 0.966, 0.963, 0.959, and 0.915 Newton. Like for the first four values, the values are proportional. The differences are almost the same. However, for 20 centimeters, there is a much bigger decrease in force value. So, and this repeats for all different pipes. So it's not too accurate, as you can see. And this error may have happened because the time interval is much smaller compared to the other ones, since I am releasing the ball from a distance closer to the ground. Throughout the experiment, other factors that may have caused an error are the way I hold the pipe, since the pipe have been like not completely proportional to the ground, and the pipe may have wobbled when I was pulling the magnet away. Also, the magnetic attraction between the magnets may have caused the ball to fall slower, even though I try to hold the magnet as far as possible from the ball inside the pipe. And this is my Physics 102 project.